The next speaker will be Jean-Luc di Paola-Galloni. My middle name is Jean, so I actually know how to pronounce that. Jean-Luc is Valeo Group Corporate Vice President for Sustainability and External Affairs. He was previously a delegate member of the Executive Committee at Valeo since December of 2006. He joined the technological platform European Road Transport Research Advisory Council as Vice Chairman in 2008, representing the automotive suppliers industry, reporting to the European Commission. In this respect, he's also a member of the strategic group advising the board of the European Association of Suppliers and takes part in the electromobility working group within this business federation. He has a commitment to establish relationships between the automotive industry and international bodies with a multi-stakeholder approach, and that's also reflected by his commitment to the advisory board of the International Forum of OECD Transport Ministers. Since January of 2010, he's a Valeo board member to the Modernization Fund of Automotive Suppliers, which belongs to the state-owned French Sovereign Fund. He was previously advisor to the CEO of Gaz de France and has a research experience in the field of defense, international relations, and strategic affairs at Harvard, the École Normale Supérieure, and Institut des Hautes Études de Défense Nationale in France. I come from a French-Canadian background, and so I'm really struggling. The French-Canadian patois is a lot different. He was a research fellow at the Weatherhead Center for International Affairs at Harvard University. He holds several degrees in geography, urban planning, and humanities. He's had teaching positions at the University of Massachusetts at Boston, preparatory classes to the French Grande École Jean Monnet European Studies Center of Università di Trento, which is in Italy, Nanking University in Taiwan, and since July 2011, he has been appointed member of the Terminology Commission to the Académie Française. Jean-Luc.
Thank you very much, Russell. Good morning, ladies and gentlemen. It's a real pleasure to be back for me the second time in, I would say, less than 7 months in Greenville, Virginia. And I would like to thank you all, and particularly Clemson University and QuiCar and ASICAE, because it was really between a transatlantic cooperation that I was privileged to know this part of the country and this wonderful area and new region of US automotive. So, I will present today what is, I would say, Valeo full strategy of CO2 reduction through electrification, not only full electrical vehicles, but also the hybrids. As you know, the CO2 reduction is a question that relates the weight of the vehicle and the CO2 emissions. So, what we need to do through these charts is obviously to lower the level of CO2 emissions proportionally to the weight. What we do nowadays has nothing to do with what is going to be the objective. And the objectives, you know, all my colleagues here have shown the different regulation. I won't come back to that, but whatever, if you are in Japan, in the US, or in Europe, which are the regulation I'm most familiar with of the European Commission, and I helped them even design, the objective of 2020 are going to be pretty severe. In Europe, it's going to be 95 grams. And what I want to say is exactly what my colleagues, and I refer to what Jay from Chrysler said, is that even if the technology of internal combustion engine are very helpful, the move towards electrification and towards full electrical vehicle is going to be a must, because it's clearly electricity that will enable highly efficient energy recovery and at the same time storage of energy. So this drive towards an electrification of powertrain is really necessary. What has been our, I would say, as a tier one supplier strategy, our strategy to address this market? And here you see all existing cars in the market. Well, as you know, we've been the inventor in auto industry of the stop-start. So we started from the micro-hybrid. And clearly by that, we wanted to show that we could achieve a better usage of fossil energy and I would say sustaining what was already the ICE existing by first the stop-start and then moving towards the mild hybrid through a kinetic energy recovery, more and more engine assistance, and preparing the electric takeoff. And the other piece of strategy was starting from the full electrical vehicle and how to address a better acceptance and going down, I would say, through the plug-in, the range extenders, and that's also the other segment of the market that we address. This is exactly the kind of strategy of a tier one follows in order to respond to its multi-portfolio customers. So if I start from the better usage of energy from the stop-start to affordable hybrid. Well, here, you know, what is the burden for a supplier? It's always to present to its customers, the OEMs, not only innovation, a good technology, but at affordable prices. And the problem with the mild hybrid is that, as it was known, the cost per gram of CO2 saved was too expensive, 60 euros, so not very affordable. And in this approach of ours, we try to work on an optimization. We work on the architecture study, on the electrical machine performance, and on the vehicle speed profile study in order to find an affordable hybrid solution. And so we reach a target to really diminish this cost and get it below 35 euros per gram. So we have seen different solutions and different, I would say, localization where we could be the most cost efficient and CO2 reduction level, and you will see that more calmly in the chart I will leave. And here is really what we have found as a best possible balance CO2 reduction versus cost in the mild hybrid. In architecture through electric machine directly positioned on the crankshaft, or the electric machine behind the gearbox through a disconnected clutch. As far as the motor is concerned, we worked on a mixed motor machine of 8 kilowatts and power electronics with 60 volt maximum, 48 volt nominal, and an energy storage between 40 to 150 kilojoule. So this hybrid for all demo car is now ready, and that's what we believe in the mild hybrid solution, which will bring a minus 15% CO2 reduction on a general mode, which is, I would say, a multiplication per 2 of what would be the micro hybrid with the start-stop. What is our panel of solution for use of non-fossil energy? So basically from electrical vehicle to the plugins. Here, clearly we have had a total system approach. The picture you see is a test drive we just had last year with JKN in north of Sweden in very severe conditions. That would be the one of Alaska here in North America. And here the challenge for full electrical vehicle solution is clearly for us, first, the versatility, second, the affordability again. The versatility is clearly, we already spoke about it, it's to minimize the range anxiety. So what we're doing in this second generation of electric powertrain that we're bringing It's to offer a fast charging without extra cost on both vehicle and infrastructure. And as far as the range extender is concerned, we're developing a new compact high voltage generator inverter. But as we are a full tier 1 supplier that develops technologies in a lot of other areas than just powertrain propulsion, we just don't think that the only solution of making a better acceptance and a lower level of reduction of CO2 emission that will bring only this, the solution only through powertrain propulsion. We, as you know, are historical also tier 1 internal solution, and we had designed a heat pump system, heat accumulation, heat regeneration adapted to full electrical vehicles. And also, as a comfort and driving assistance system tier 1, we have studied that with electrical vehicles, the preconditioning of the car will have a certain impact also on the optimization of electrical energy consumption. And through smart key and preconditioning, we can also optimize of 3% the electrical energy consumption. And last but not least, we're also present in lighting, and our specialists of LED have designed and proved that on electrical vehicle, LED also optimize. It's a little percentage, but we need to use it, it's 2%. So at the end of the day, the new generation electrical vehicle that will be ready for 2014 are improving their efficiency versus the first generations that are running nowadays, like the examples that were quoted before, like Nissan Leaf. And it will be a total saving of 40% on the generation 1 electrical system. Why is that? Because, as we know, everywhere in the world, right now, the market of electrical vehicle is being subsidized. But I speak, and I'm telling you, working as an advisor to the European Commission, as you know, our old continent, and unfortunately we're not the only one, is having quite some trouble with public finance. A lot of states are in sovereign debt, and as you know, member of a corporate company, I really wonder how long the state, at least in Europe, will have the power to subsidize the market. So the industry should provide solutions that are going to be really affordable in the market, even once those subsidies won't exist. And this is our belief, and that's why a 40% efficient improvement on the second generation of electrical vehicle is what is going to reduce the cost of clearly the full package of electrification, not only the battery, but also through the what will be the new components. Sorry, I went too fast. The lowerage cost of the battery itself, because it will grow in terms of volume. And clearly what we're seeking is to have a lower cost by 2015, because if I speak for France, we know that there is going to be a complete drop of subsidies by the next 3-4 years. So clearly, the cost reduction versus range increase is what we consider a trade-off for the original equipment manufacturer. So what I want to say is that here you see what we presented at the car show in Shanghai. We did it at the very beginning of the year in New Delhi. We're addressing also obviously the very important emerging markets. But what I want to insist is that for a tier 1, what is the burden is really to present an innovative solution, but that always keeps an eye on reducing the cost. And with that, I conclude. Thank you very much.
Thank you. Well, thank you, Jean-Luc. We come now to Jake Ring. Jake is the Chief Marketing Officer for GE Energy Management, He's responsible for strategic growth across the energy management portfolio. He's accountable for setting and driving the vision that leverages GE's energy management business and services into a comprehensive solutions portfolio to drive customer and business success. He leads the development of strategy and commercialization initiatives across energy management globally and guides the development of markets, adjacencies, and new technology areas for the business. Most recently, Jake was Chief Operating Officer for MTech Holdings, a private equity portfolio of electronics companies. Prior to that, he was Vice President of Sales and Marketing for a private equity-owned manufacturer and distributor of RF/microwave components and assemblies, where he managed call center and distribution sales, direct marketing and e-commerce, and also product development. Jake has several other very impressive back jobs, but to move on, I just want to point out that he received a BS degree in math and computer science from Vanderbilt and an MBA from Washington University in St. Louis. He's an active member of the Direct Marketing Association. Your turn, Jake.
Okay, well, it's certainly a pleasure to be with a number of people who like the car industry like me. My first job out of college was working at the GE assembly plant in Doraville, Georgia, where I was running PLC programming and automation for the Cutlass, Oldsmobile Cutlass Supreme. So it's always a pleasure to be talking to a number of fellow engineers. Wanted to talk first about this little company you may have heard of called GE. Been around for a little while, since Edison started us more than 100 years ago. In 2010, our revenue was over $38 billion, over several different groups. You can see that the energy business represents about a third of the total revenue, with healthcare, aviation, transportation, and our home and business solutions group, which makes the appliances as well as light bulbs, and then of course GE Capital, which provides financing. Within GE Energy, there are three businesses. Our CEO and president is John Kranicki. He's also vice chairman for GE. And last year, our revenues just topped over $44 billion. The three businesses are oil and gas, which provides the upstream and midstream equipment for exploration and drilling and servicing, as well as then in the power and water business, that's our power generation business. So nuclear, all of our renewables from our wind turbines and solar turbines, as well as the gas engines and gas turbines. Then in energy management, got a little messed up there, but we deal with the electrical infrastructure. So our business, my business, is focused on the transportation of electrons from once they're generated to their source of use. And so I'm going to talk a little bit about that because while my esteemed colleagues here on the panel are talking about the use of electricity, the infrastructure is also a really important factor. GE Energy is around the world. We have in GE Energy, we have over 100,000 employees, representing a third of the business overall. And so as we focus on the growth of the electrical vehicle market, we see that there's a lot of compelling changes that are taking place. And the first question is, why now? Why will they succeed now? There's been a lot of talk and a lot of discussion. My esteemed colleagues here have also talked about it's the need for being able to decouple from that volatility of oil in the petroleum market, and also a desire to reduce greenhouse gas emissions. But it's important to be able to mitigate the risk that is associated with that. If your business is dependent on sales professionals having mobility, whether it be in the pharmaceutical industry or shipping industry, such as with FedEx or UPS, you want to be able to offset that risk that volatility may cause. In addition, there's a competitive edge that's going to be coming. When governments and other organizations are providing subsidies and incentives, there's an opportunity, just as when NASA was being formed and new materials and new developments were coming out, to be able to take advantage of those development efforts and leapfrog your competition. And so we see that there is definitely going to be the capability for achieving what the President said back in his State of the Union address of over 1 million vehicles on the road by 2015. So if that's what success would be, what will success potentially look like? Here we have a chart in the upper left-hand corner that talks about this as the growth of the electric vehicle market over the next 3 years. It'll take about 400,000 annual sales by 2015 to achieve the kind of growth momentum. But there's going to be more chargers needed per vehicle. We'll look at that. It's going to be about 1.4 charging stations per vehicle. And when you look at the preference, when we ask potential customers of EVs, where would they like to charge their car? Overwhelmingly, about almost 2/3 would prefer, of course, to do it at their home, but then there's a need for having it not just in the office, but also in just in a public place, because they're planning on using that vehicle for doing their transportation outside of their home. And so we look at the potential growth here in the breakout just in the US market, and of course there's a huge potential for balancing the needs of both the home and the public use of electric vehicles. And in so doing, that's going to require a very robust ecosystem, because the external business or the external charging capabilities are going to be dependent upon a public and private partnership capability of being able to build that ecosystem. And this is where GE plays. We're in the power generation space. As is pointed out, our power and water business is providing not only the steam turbines and gas turbines that are generating electricity, but also the renewable sources in wind and solar. We just launched a new plant in Colorado that's going to have over 400 new jobs to produce electric photovoltaic solar panels. But importantly, it's also, my business, especially important, is the transportation of those electrons. It's going to require a smarter grid, not only from transmission, but through to distribution, because for every one of those vehicles, as you know, it's going to be either 3.3 or 6.6 kilowatts per hour charging. And if they want to have a higher rate or speedier charging, they're going to need higher voltages. And in order to maintain that those grids will be well balanced as these additional loads come on, utilities increasingly are concerned. What can they do? How can they use technology within their own facilities and in grids to be able to help balance and indeed even manage the loads that are going to be out in their grids? And then the infrastructure use, as well as how that load is going to be used within commercial and industrial applications. And so we provide charging capabilities. Not only do we offer solutions that cover all of those different aspects of power generation in the grid and in the infrastructure, but also we provide a charging capability that would be out in the public place, in our Watt station, our pedestal. You've probably seen maybe the commercial once or twice, as well as then in the home we have a wall mount. And this device would be able to provide greater charging speeds and also a way to be able to help utility companies mitigate and balance the loads that customers may be having for wanting to charge and be able to get preferential rates. Because we do know that once customers are able to see what their power consumption is, it will change their behavior and affect when and how they start using their electricity. So I mentioned that there's a need for then creating a robust ecosystem, and a great example is what's taking place here in Greenville. We have a number of public pods, two actually, that are being sponsored and being built out, and it's being spurred by the local government, but also with the participating businesses that are within the Greenville area. Over 25 companies, for example, have committed to supporting that. In another month or two at Greenville-Spartanburg Airport, there will be a pod of electric vehicles so that when visiting employees come in to the area, they'll be able to rent the car, the electric vehicle, and be able to take that vehicle, go and either charge it at the business's location, but also in one of 3 major hotels in downtown Greenville. So that kind of an ecosystem will help promote the use of electric vehicles. In addition, there's a public pod that's going to be downtown that's going to be sponsored by Enterprise Rental Car, where customers, visitors, or shoppers into the Greenville area will be able to rent the cars on an hourly basis, do their shopping, do their travel, do their visiting, whatever they want to do, and be able to return the car and be able to get preferential rates based on how long they want to rent that car. And so this kind of a participation is what will help spur the growth and the application, because it really is going to take that kind of a push. It can't be just from a government, it can't be just from a business, it's a partnership arrangement that will help promote and use that. And this is really to our knowledge, this is the only one in the US. So it's rather amazing when you consider, for example, in San Francisco or other areas that tout themselves to be green. That's Greenville that's actually the one that's really doing it and putting where their money is, putting their money where their mouth is. So, what's GE doing in addition? We're helping sponsor other alternatives. People have talked about, well, what if we used solar to charge EVs? Okay, we've put together a 100 kilowatt grid tiered solar system in our Plainville, Connecticut location, which is where GE's Industrial Solutions business is located. It powers the parking lot. We'll charge up to 10 EV chargers. And GE's made a significant investment in trying to promote this by also committing to buy up to 25,000 plug-in electric vehicles and full electric vehicles, most noticeably like the Chevy Volt that you see there in the picture. Now, this will offset, energy of the charging of that 6.6 kilowatt hours per day for those up to 13 vehicles. But it's just to prove that this can be done and to show that it's not that expensive in order to do it, that it can be sustaining. And we're also partnering with many organizations in order to help promote and provide this technology to customers. So not that you have to actually get that car and buy it from the dealership. If you wanted to convert your existing Prius into something that would be an electric vehicle, you can go to Lowe's or Home Depot or any of the other, Best Buy, or any of the other participating organizations and get that wall charger for your house and be able to have that now become a full electric vehicle. But also we're partnering with other organizations. Enterprise I mentioned, Hertz, these hotels that are, these chains that are wanting to go ahead and provide this infrastructure for their customers because they also see that this is going to happen. And in the next 3 years, as we see the growth starting to take place, even though Hamtramck has ramped down a little bit, there's a renewed push that's coming, and we're expecting to see that this is going to continue, especially when you're looking at $110, $130, $150 per barrel being a possibility. That would help only promote this growth of capability. So, thank you very much, and we look forward to taking your questions.
Okay, we're going to take a few questions. I thought when I came in there was a microphone over there, but right now I can't see it. It is over there. So if you, I would appreciate it if you have a question. Could you step over to that microphone? Is there one on the other side? Yes. Okay, so we have microphones. Do we have questions? Aha. I hope, let's see. I think somebody is getting ready to step up to the microphone.
My name is can you hear me? Can you hear me, my question?
I think it's on. Is it on?
Okay.
Okay, go.
My name is Shapan Das. I work for OnStar, and I'm also an IEEE member. I think Dr. Weber mentioned that everything is there, but only thing is missing is the customer. Customer is not buying. And also, I think Dr. Brown mentioned about the if you can add value, then customer might come and buy the vehicle. My background is wireless communications, where I have seen that customer is buying smartphone because they are giving more value for applications over the availability, which used to be the value for 10 years back. And they're paying $400 for a phone, although it might cost only $30. My question is, what can be done for this electric vehicle industry so that customer is willing to pay more money instead of looking for subsidy and buy this car? And will least bother about the range anxiety or any other constraint right now we have. So can you throw some ideas that these are the things like a customer may look into as a value and they least bother about all other concerns?
Anybody want to take a... Okay, Andrew?
Is my lavalier still working? Oh, if not, I can use this. Very, very good question. Certainly, the smartphone is a model that's out there where people are certainly willing to pay additional for the feature functions of that smartphone. It doesn't translate seamlessly to an electric vehicle. However, it's not lost on an electric vehicle in the sense that if you think more broadly about the electric vehicle, and I think Jay touched on this a bit, the idea of really a connected vehicle in the sense that now the vehicle provides more functionality. Now, if you pack in the electric vehicle, HEV, into that equation, now you might do some things as optimizing the performance of the vehicle based on terrain, based on the driving or duty cycle of the operator, and then include in that some of the additional connectivity features that actually are provided by the connectivity, whether it's 4G, whether it's DSRC, things of that nature. But I think fundamentally, the competition presented by the internal combustion engine and the continued improvements in those power plants will be the bar that the electric vehicle has to meet. And so if we can provide a performing product that's reliable, that has quality, and that gets close to the affordability issue of the average consumer. In other words, a cost to them that's somewhat equivalent to that of an internal combustion engine, while at the same time providing some additional functionalities, I think you start to get a viable value proposition for the consumer. But don't forget, we still have some issues to solve, and the biggest issue out there remains the battery.
Anybody else? Jay?
Can you hear me okay? Okay. I completely agree with the comments made by Dr. Brown on this. Is having a connected vehicle provides more to the customer than today's vehicle. Also, if you take a look at plug-in hybrid technology, you can provide easily capability for export power. What I mean by that is having the capability, having a mobile generator with you, so that when a customer, a truck customer, for example, is going to work sites, they can easily carry power with them. So it makes it a whole different paradigm of what the vehicles can be used for, in addition to being supporting mobile microgrids and becoming generators, so that the customers can benefit from having power with them wherever they go. So there's multiple benefits of the system depending on how you look at the technology. And again, the costs must come down to be able to, even with all of that, to be able to make it affordable to the customers.
Andrew has something else to say.
Just an observation. When you think of the smartphone, you only have, what, 3 or 4 major telecommunications providers, right? You've got Verizon, you've got AT&T, et cetera, et cetera. Think of this issue. When you think of providing power to an electric vehicle, you have over 3,000 utilities or areas that are responsible for the generation of power in this country. And there is no single entity that has responsibility for all of them. So now you have protocol issues, you have charge rate issues. It's not like the telecommunications on the smartphone. We have a lot of work to do to get those communities together. Not that it's insurmountable, but a lot of work to be done.
Can you hear me? Yep. Thankfully, at least the charger, the plug, at least is common. Like with with phone companies, where right now, if you don't buy the right plug, you're stuck.
Okay, I think the next node's over there.
Yes. Can you hear me?
Yes.
All right. My name is Greg Olson from Princeton Power Systems in Princeton, New Jersey. I've been a Tesla owner for 2.5 years, and if anyone wants to, ask me about what the experience is like, look me up. I love the car, and I've had great experiences with it. My utility gives me half rate after 9 p.m. in New Jersey, so I'm a satisfied customer. My question is, a couple of my companies have used a fleet of pickup trucks, delivery vehicles, and they've not had great success in trying to find a commercial source of electric vehicles for that. Can anybody in the panel make some recommendations there?
I'll speak to that. I won't make a recommendation, but there are some manufacturers today that have more than just prototypes, that are actually providing working technologies that are available in the marketplace. And I would suggest that you might check with ATA, the American Trucking Association, or the other trade associations for some of their recommendations, or at least you can get a list of current manufacturers of powertrain electrification systems for medium-duty and heavy-duty vehicles. They're out there, and they're actually providing systems.
Anybody else?
I guess the question was not intended for BMW.
I do want to make a point, though, related to that. The U.S. Air Force has made a commitment to convert the fleet at the Los Angeles Air Force Station to all electric. I don't remember what day, but it was something that came up within the last year. Okay.
By the way, one question. How many people here own an electric vehicle? Could you raise your hands?
There's a few.
Well, if you know, the Chevy Volt plant shut down last week for lack of demand. And you can ask yourself, if we're not buying these things, who is?
Well, one of the problems which has been talked about is that it just takes time to bring in new vehicles. Okay, next.
Yeah, thanks. This is ML Chen with ML Consulting Group. It's not, you can hear me, right? Yeah, basically the question is that I think as Andrew brought up, I think the market right now is really driven by China. And as you know that we all have a lot of infrastructure, the charging infrastructure was the main issue. So China is kind of pushing that. But I'm just wondering, so if China is pushing it in a different way. I mean, they're pushing on battery swapping, trying to bypass the charging infrastructure issue. They're trying to focus right now very much on the what they call the hybrid electric vehicles rather than battery electric vehicles. So I mean, do you see a trend kind of moving towards that direction rather than the kind of issues we're talking about in the U.S., where there is no home charging infrastructure in place in China, I can assure you. So that's one question. The other question is again related to the international market. And there are quite a few key players in the international market. They are not interested in having their existing gas-based vehicle market being eroded by electric vehicles. You really see a sort of a tension between the two markets going on right over there in Asia, since Asia is sort of a major driving market for these electric vehicles. So two questions.
Anybody want to take a shot at that? I do point out that Denmark, for example, has committed pretty much full up to battery swapping, but they're kind of it has to do with dealing with Mitsubishi. I'm not sure whether any of the others are. I'm not sure how they do that without some sort of standard for the rest. Okay, go.
Yeah, okay, I try to comment on the battery swapping. My first take on that is we do battery swapping. All our forklift trucks back in the production plant in Munich and in Spartanburg here do battery swapping. And that's an honest answer in terms of for what kind of cars or vehicles battery swapping I think is the right solution. In all kind of passenger cars that somehow should appeal to a customer, the battery is such an integrated part of the overall vehicle architecture that I don't think standardizing the overall battery system is the right solution. I mean, battery swapping is a perfect solution as applied in China for buses, for trucks, for operating vehicles like forklift trucks and so on. But I don't think that we can build any really appealing car around a standardized battery. The second thing is the battery is a high investment part, a high cost part in the car. And just imagine you just purchased your car with a battery and you always took good care of the battery, then you swap the battery and you unfortunately get the one in your car your next door neighbor used to usually just push the battery very hard. You're not happy with that. From a technology point of view, the third answer is future batteries probably will be liquid cooled and you have another interface in the car for the cooling liquid, whatever it will be. You always have to open and close, and I think that is one of the reasons why we, at least from a BMW side, we do not really go for battery swapping.
Andrew?
Yes, with regards to that, the question on battery swapping, I think we need to realize that there's some difficulty with that, recognizing the fact that each vehicle, each OEM will have their own architecture that drives the battery chemistry. I mean, think of it very simply, whether you have a series versus a parallel hybrid, how you split the power between devices, whether you're emphasizing specific power over specific energy, that is range versus power. I mean, if to do battery swapping effectively, you have to have a set of assumptions that pars down some of those factors, and that reduces what the OEM wants to do with the vehicle. Again, getting back to the architecture that the OEM wants to implement. I mean, that's why a BMW is not some other vehicle, for instance, because of the unique architecture and characteristics that that OEM wants to build into it. So the battery swapping will have applications, okay? And it will be successful in, I think, some very specific applications. For instance, if you're at a depot where vehicles come and go each day, in other words, they start and end their day at the same place, you have essentially the same type of vehicles. Think of a truck delivery or cargo delivery. Those kind of applications would work well for battery switching. So a lot of issues around that. Secondly, with regards to the China situations, I think China is now learning from their emphasis on battery electric vehicles that maybe they've challenged themselves a bit too much. And there's even some indications that they're looking more at HEVs as a bridge strategy to BEVs. So a lot to be done in this whole arena. And to get at it, it's going to really depend on many of you in the audience to solve some of these technical problems and market problems.
Jean-Luc?
Yes, I will complete what Dr. Brown just said about China with, I would say, a comment that has actually nothing so much to do to what OEMs and suppliers can provide as an answer, but a comment on what is the China situation. When the Chinese government and each province launched specific programs on electrical vehicle, you have a situation where, one, they have the money to subsidize. Second, it's a special political situation. government are much more empowered for the right reason that you know. It's not a democracy. Third, you have a huge demand, a huge private demand for more and more cars, to the point that now each governor and each mayor of big cities need to regulate the supply of this demand. That is to say that the demand is higher than what can be an urban planning acceptancy of new cars in big cities. And you have a political situation right now, particularly in this transitionary period before moving to the new president, where each big governor and each big pilot region on electrical vehicle are competing one against the other to bring the new solution on real CO2 emission reduction. So what do they have noticed is that for the full electrical vehicle, obviously they are much less advanced than what it is in plug-in and hybrid in range extender. And we have been facing, even with the Chinese OEMs that we supply there, where they wanted very fast delivery solutions for what was the most available. And what was the most available immediately now was not full electrical vehicle solution, but the electrification solution, that is to say again, mild hybrid, plug-in, range extender.
I'll take one more question and then suggest that, do we have another question over there? Ah, we do. Yeah, I know. What I'm going to suggest after this is asking people who have questions to come up and interact directly with persons on the panel. I'm sure they'll be more than happy to talk to you. Okay, next.
My name is Braj Bhargava. I'm an IEEE member. In fact, this year I just got the honor of becoming a life member, as a matter of fact. I design electrical machines, mostly for aerospace applications. And I see electrical machines, our powertrain is one of the key components of hybrid electric or electric vehicles. I would like to know from even OEMs and others when they are going to take the lead or initiative to develop efficient, cost-effective powertrains, which are going to be the future of these electric vehicles and a key component, rather than depend on some companies to make the drivetrain and buy the motors, for example, for their vehicles, which I don't think are as efficient or cost-effective either. Thank you.
Yes, I don't want to give an impression that the OEMs are sitting and waiting for the components to be developed. We are very actively involved in vertically integrating ourselves into be able to design and understand the physics behind things like electric machines and power electronics. So there's a lot of investment on our side to get into the details of those components, for the simple reason that if you ask me what my biggest problem is, it is cost. It is not efficiency. We can always get efficiency, but the cost is one of the biggest reasons. We're looking for modularity of various components and systems so we can go across multiple vehicle platforms and multiple technologies. We are looking at economies of scale, where could we share certain components even with a competitor, if that makes sense, to get the economy of scale. We're looking at new business models. We are constantly looking at how do we make this technology affordable so that it can be deployed in the mass market. So I don't want to give an impression that we are waiting for somebody else to develop this.
Andrew?
Yes, with regards to the question, I think we need to realize that not all OEMs are created equal. And what I mean by that is there are various capabilities that each OEM has. Some are fully capable and able to do as the questioner suggested and have that entire in-house capability, whereas others don't have all of that capability. In fact, some are totally new to the marketplace. And so for them to take on designing and manufacturing all of the components associated with an electrified powertrain would be difficult, if not prohibitive, number one. And secondly, I would, going back to our speaker earlier today, one of the crying needs that we have in this space is more graduates in electric machines. If you actually look at some of the curriculums around the country, that's one area that has dwindled in our academic institutions. And so that's an area where we can help ourselves by fostering and supporting more academic programs around electric machines.
Jean-Luc?
Yes. Well, one OEM that is not present here, but has just made a very recent move last week in taking 7% of stake in Peugeot, and it's GM. And so I really don't think we can say that OEMs are just waiting that component system. I fully agree with Jay's reaction. And what I want to add as representative of another supplier is that we work hands in hands with OEMs, and it's a supply chain, I would say, collaborative approach. So nobody's waiting, and we're very active, and just check the level of expenses of R&D that we're doing.
Yeah, go ahead.
Would like to add, I think, for example, if we talk about battery cells, this is definitely something probably no OEM, correct me if I'm wrong, would step in, because this is really a commodity like nuts and bolts today. But in terms of differentiation, battery modules and systems, and also especially the electric engines, for us are parts we definitely develop by ourselves. And in that new joint venture, you just mentioned it, with BMW, Peugeot, Citroën Electrification, which designs and produces batteries and motors.
I'm going to end, but I just want to add one thing to what Andrew said. Last October, I chaired a panel in the Silicon Valley that was sponsored by the IEEE Electric Vehicle Committee and Spectrum. John Volker, who is perhaps the best journalist on electric vehicles, gave a talk, and he said that that the EV community was, and I don't remember the word, I'll use desperate for certain kinds of people. And he mentioned if you have a specialty in mechatronics, that you could walk into any number of electric vehicle manufacturers and pretty much name your own price. And with that, I'm going to close this session. We're a little over, but that's okay. I suggest that if you have any more questions, you might want to come up and address them directly to our panelists. And I'd like to ask you to give us a hand for a really terrific panel. Thank you very much.